All right, so in case you fall asleep, these are the key takeaways of this talk. So DDSEC, it actually helps you to design secure software without thinking about security. And that's a fantastic property, and you will find out in this session. We're also going to talk about something called injection flaws. And we're not going to do it in the normal way. We're going to actually say that you should treat this as a modeling problem and not as a validation problem. You're going to use context mapping to essentially avoid something called cross-site scripting and second-order attacks. And we're also going to show that microservices can be really painful unless you get that context mapping covered. Right. So, as you probably noted, there are 3 different sessions regarding domain-driven security. The first one is this one, and this is one where you get intrigued and introduced to the field. And the second 2 are hands-on session, and the first one is later today at 2:30, I think. And that's when you get your hands dirty, and you actually get to touch code, bring your laptop, and hopefully everyone has a voucher that wants to come. And then there's a hands-on session tomorrow where we actually do a look at some deep stuff and get some deep insights and think about what can we actually do to bring the field forward, or what should we have done, and so on. So they're in-depth discussions along with presentations of subtle insights.
We hope to cover some more like subtle questions that might seem trivial, but when you dive into them, it's actually pretty fundamental to where you go.
Right. So this talk, today we're going to cover 4 quadrants. We're going to look at something called simple domain attacks, simple technical attacks, something called complex technical attacks, and of course complex domain attacks. Since this is an introductory to the field, we're going to focus more on the first 2, and then we're going to jump into the other 2. And the reason for that is because the hands-on sessions are actually diving into the latter 2 more than the first 2.
Still, we want to cover the kind of contemporary state of the art of our philosophical aspects, and those are contained in especially the complex technical and complex domain. Complex in this sense meaning there are more than one system.
Right.
Simple meaning there's just one system. I want to tell you a real-life story. This were a few colleagues of ours who did a penetration test, a security test, on a website. They were doing it on their production live website, which were a Swedish reseller, or detailist reseller of some product. We can't disclose which one, and it was not books. So let's say they were selling books, just for the sake of the example. And they were fiddling around, trying to shoot in different stuff in different text fields, and didn't really get anywhere. So one of them got curious and thought, this order here, if I change the quantity to -1, what happens then? So basically ordering a negative encyclopedia, which is what we got here. Did it, and to his surprise, actually nothing really happened. The order went into the system, they went through the payment procedure, providing the credit card, etc. And yeah, it was weird. I had expected something to happen, so I made a small note. Next day. A woman from the economy department enters the tester room with a piece of paper in hand, saying, "Excuse me, is anyone here Joe Tester?" We're like, yeah, that might be us. Yeah, because we got some really weird here. The credit system has just printed out a credit invoice issued to Joe Tester. And the postal address is the postal address of our headquarters, where we are. so we don't really know where to send it. Is there any one of you who should have it? So the system has actually reacted by trying to give away the money that correspond to a not encyclopedia. Okay, could this have been used in some other way? Yeah, perhaps we could have done this together with ordering a lot of books, and then we should find a way to make a rebate. So this is something that requires domain knowledge of it's a simple example, but it requires domain knowledge to understand that this is actually a security issue. So this is the simplest example of a simple domain attack. So the technical way of solving this, or approaching it, would be say that this is a validation, in-data validation problem. And the UVASP security guidelines actually say that to avoid in-data validation problems, you should validate your in-data. Yeah, that's helpful. So they actually give some code examples, and they say you should write stuff like fill it with guards if value is less than don't. The problem here is that kind of like encourage a separation of the validation regex, or whatever you got, and the data and the business process behind it. So it pushes a lot of validations to the board of the system. So it'll be riddled with a lot of validation codes, and it will probably be incomplete and probably inconsistent. And if you try to solve this from a technical perspective, you end up with a whack-a-mole. Like you're trying to solve one problem. Okay, we tried to solve the validation problem. Now we've got a lot of inconsistent validation. We tried to solve that by gathering them to some util common. Sounds like a good idea. Yeah, until you realize that now you've got a util common, which has got dependencies all over the place. And now you're trying to go to a microservice architecture, and then you just, yeah. So, let's take the analysis from a DDD perspective instead. Our observation that quantity in this case is actually modeled de facto as an integer. But it's made implicit. It's an implicit concept. And there's nothing wrong with that. You have that all the time. What we need now is to make that implicit concept explicit. So the modeling was incomplete or missing. We had kind of discussion with the domain experts, and they said something about quantity, and the developer thought, yeah, that's an int, and then you're done. So what do we do about it to take it in a domain-driven design way, to apply domain-driven design for solving this security issue? Well, instead, we try to model this as an explicit concept, a quantity. So that order line will probably have an ISBN, it will have a quantity, it might have other, and those are not primitives. Those are domain primitives, not language primitives, but our domain primitives. To be very, very concrete, we'll end up with some kind of class saying, we've got a quantity, it's got a value on the inside, we have a guarded constructor stopping it from doing stuff that is not model-wise sound. This might seem trivial, but this is actually, in our experience, this is a stepping stone. You start here, and you will get wonderful benefits from it. Just to point out one obvious thing. You have to go, we can note here that the value must not be 0. That is probably a modeling decision after a conversation with the domain experts. So if you have started a conversation with the domain experts on the lower bound, well, what's the natural next question?
Upper bound.
What's the upper bound? Is it sensible to order 1 million books? Should our domain value object allow 1 million books? That's not sensible. Is it 100 or 10? to our surprise, we actually had experience that we were ordering a lot of books, 150, for a student conference. And we went through a respected Swedish reseller online, and that system just totally broke down. They accepted our order, but they couldn't deliver on it. And it ended up we having to call them by phone, landline, not even mobile, to be able to talk to someone who could say, we're sorry. So their system was probably obviously not designed to recognize that we have an upper bound of what's a sensible quantity in relation to our logistic stream. So we end up with, if we do this consistently, we'll go from having buy book taking strings and ints to having buy books on some kind of ISBN and quantity. So we build this library of domain primitives that kind of like raise the floor for our discussion and for our code base, making that our entities or services will do much less work. The code will be much shorter, much crisper, so to the point that we can actually sit in front of a domain expert, non-technical domain expert, show them the code, and they will say, yeah, that's how we do our business. So,
right. So there could be other concepts that need to be made explicit. Because of the API now, we just learned that we should not use the primitives or generic types such as strings or objects and such. So then you start thinking, well, that quantity, that was kind of simple. I have an email address, so I should create some sort of domain object representing that email address. It should not be a string, right? So we go on this path, and now we see that all of a sudden we're going to write our guard. And we go like, wait a minute, what does an email address look like? So we jump into, of course...
I know what an email looks like. It's specified.
It's specified according to the specification.
Yeah, RFC 5322, section 3.4. Anyone's read that one?
We all read that one, right? And
Before you sent your first email, you read the spec.
Then you Google it, and you find out there are regular expression lovers out there that has interpreted, and they provided this fine, spectacular regular expression that goes on for another 6,400 characters. And it's like, should I use that? Well,
yeah, that will fit into my code base. I better put it in a property file.
Well, as it turns out, like Eric Evans talked about in the keynote, that no, you need to make sure that you design your domain objects in a way that is suitable for your bounded context and your model. So for the email address, of course, you should not accept everything unless you need to accept everything.
Did you notice that these are actually legal email addresses, according to the specification? Yeah, you want those as contacts in your database.
I mean, you should really talk to your domain experts and say, okay, what kind of email address are we supposed to accept? Should we accept emails from every domain? Could it be just .com, .se as it in Sweden, or what else? Should we accept these crazy characters in there? Maybe some of them, maybe not everyone. So you basically narrow down your model and let it grow. That makes perfect sense. So we talked a lot about domain-driven design, sort of say. So what is this domain-driven security? Well, like I said in the beginning, domain-driven security is all about picking tools and concepts out of domain-driven design and use them to actually address certain security issues.
Okay, but Daniel, seriously, have we solved any security issues? We have been doing some domain-driven design here.
Well, as it turns out, that -1 was a business integrity issue. By simply modeling quantity, upper-lower bound, we were able to narrow it down so that we don't accept that anymore. And by magic, that flaw just went away.
Yeah. Security comes in a lot of flavors, like confidentiality, or availability, or traceability, or integrity. So we did not solve a data or business confidentiality issue.
No.
But we did solve a business integrity issue.
And
The
something
business was not sound any longer.
and something that I really like is the fact that sometimes when you try to tell your, I don't know, your project manager or whoever decides, the guys with the budget, we want to do DDD. And they go like, no, 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 that's way too expensive. It just takes too much time.
Anyone tried that?
You
Got that
probably all
response?
encountered that one, right?
You want an extra argument?
And now I've just added one more weapon in your arsenal. You're going to tell them, do you want to address these security problems? And they go, yeah, security, that's very, very delicate business. So our tool is DDD. Fantastic. So now you can do DDD just by chance. Okay. So let's move forward.
Okay, now we have the look at the simple domain attacks and try to introduce the field of domain-driven security. Now we're going to speed up a little bit and dive into the simple technical attacks. Meaning simple, we're still just attacking one system, but we're doing it from a technical perspective. Most of the time using technical means, and most of the time with a technical objective. Trying to get to the database, trying to get to the infrastructure, trying to get a root shell on some server. That's kind of like Holy Grail for being pawned.
Okay. So the number one on the OWASP top 10 list is injection flaws. And if you don't read all that text, the quick version is that we basically are able to somehow send in untrusted data that tricks the interpreter in doing something it's not supposed to do. Right? Perfect. So you guys probably know SQL better than I do. But I mean, this is the usual case. Dan is logging into a system. His username, DanBJ. His password is obviously cats are cute. Well, that's good. And the query gets run. But then we of course have that evil hacksaw guy or girl that realize that somehow that SQL query gets built up in a certain way that we're able to pass in a statement or 1 = 1 that evaluates to true, and all suddenly we get access. Okay? So let's look at a demo for that. Those of you that will be in the hands-on session later on today is going to get familiar with this app. It's called Facepalm, and it's mostly written of one of our colleagues, Daniel Hultquist. He's a lot younger than us, and he understands those cool things. It's supposed to be some sort of, oh, what are you doing? Showing my family. That's good.
Facepalm.
Fantastic. All right. There's supposed to be a fusion between something called Instagram, Facebook, 9gag or something. I mean, those fancy kids. Yes.
Okay, now I'm happy to let you write with your keyboard behind your back.
Thank you.
Sure.
Okay. Been practicing all week for this. Okay.
But we remember what the evil hackers used. And it happens to be, hey, Daniel, are you using that as a login often?
Oh. Sorry about that. So which password should we use? Anyone? Okay, that one. That's pretty good, one-handed. So now I'm just going to hit the sign in button. That was interesting.
Demo bug.
Demo bug. Let's go back.
Not prepare statement. Which branch are you running?
No. Here we go. I forgot something. 2 very important characters. The dash, dash. Why is that? Because after 2 dashes, we say ignore the rest of the SQL statement. So let me hit that button again. Oh, yeah, sorry, I need to repeat my password. There we go. Come on. There we go.
Master password.
By magic, I was able to log in. Now it's the time when you get, you know, sort of excited. Okay. So, Dan, what have you done with the screen?
Yeah, I think I might be able to get it back. Perhaps. No promises.
Okay. But as it also turned out,
one
thing that you didn't see there was the fact that I became admin. And those of you that are going to be in our hands-on session will understand why. So let's move on. So what was the problem and what's the solution to this? Well, as it turns out, or1 equals 1 dash dash is not a valid username.
When we ask the domain experts, that's cheating. That's not a proper username.
And the fact is that when you ask the domain expert that, it's only made implicit in the code again, like that -1. Because why? The developer's like, we know what, a username, that's just a string. And we really need to model this and make it explicit. Right. But then you start Googling SQL injection, and then you realize, wait a minute. I've found something called prepared statements, or parameterized queries that separates, data from command, basically. Really depends on what kind of solution you have in the back. But then it's like, we covered this injection flaws by just using those prepared statements. But wait a minute. OWASP does not say SQL injection is the most common one.
They actually did, but that was 10 years ago.
Oh, yeah. But the fact is that there are so many other injection flaws. So it's injection as a whole. You can inject a lot of things. It could be LDAP, command, XPath, HTTP header. HTTP header. That's pretty interesting thing.
HTTP header.
Dan, please explain what that is.
You can actually inject stuff in an HTTP header. In the response of an HTTP. I think that's a pretty neat example of how injection is not just about prepared statements. So you all know what the cookie looks like. You have some kind of API where you create a cookie and you push it onto the response, basically. In this example, we got a cookie that is on a site where you read articles. And the cookie is trying to keep track of which author you're interested in. So, for example, I'm interested in the writings of Jane Smith. I have that somewhere in the database, in the session, in the user settings, it's on the response, somewhere. The system picks up that, well, this user is interested in Jane Smith. So the author value is rendered on this part of the set cookie, which is in the HTTP header as defined by the specification. Fair enough? Okay, someone see a problem? What if I, as the evil hacker, manage to put another author into the database, into the setting, or in the response or in the session? For example, the author, while a hacker /r/n HTTP 11 OK, basically crafting my own HTTP response and putting that into the cookie. Yeah, what will happen is that the system will happily render the HTTP 1200 OK, set cookie author, and start writing out the cookie value, which will inject into the HTTP response, inject my crafted HTTP page, pushing the rest of the real content in front of me. So now I've got two responses on the TCP response stream. With some luck, the browser will just have a quick look at this one and then realize there's a second one, skip the first one, and show the second one. Or it will be stored on the network stream, and the next request from the browser will give my response. We can make it even more elaborate. If we get access to some point where we can manipulate the response length, we can craft our own response length and actually just cut off this part. But the effect is that we have inserted content onto the stream, thus giving the poor user our hacked version of the website. So we are controlling the browser from now, or the browser content. So what's the problem? There's a specification. Well, I see that two facets of this. We, as application developers, we should have taken the pain to actually model the author content, the author value, so that it cannot violate the specification, pushing in this empty control line feed that ends the message header and traverses over to the message body. So the fault is partially ours. But if you should distribute guilt a little bit, which I think always is a nice idea, someone else should have done something. Those who crafted the Java Servlet Cookie API, they could have modeled their API so that the content that was sent into the new cookie cannot contain stuff that breaks the surrounding model of cookies and HTTP responses. And it's actually something that we see in the APIs, Java APIs specifically, over and over and over again, that the hard parts are always just modeled as strings. SQL, it's a string. A cookie, it's a string, etc.
But strings are so beautiful.
Yeah, they are. So, of course, just to point out the obvious, how domain-driven security comes to direction injection flaws. Now we looked at two different kinds of it. We're like a little bit past halfway our presentation. So domain-driven design helps to separate data from code. With a focus on modeling, we create a model for the data, and that avoids us to spill over into code, especially if we got a strict type system to our help. And we can never say that we validate stuff. We always say that we validate towards a model. It's kind of very parallel to what Eric pointed out in the keynote, that the model, you always have to be in relation to something. So you can't say you must validate your in-data. That's totally meaningless. You must validate data, and this is what DDD brings to the table. You must always validate towards a model that is explicit, spelled out, crafted. Just to end with a quick note on validation. Earlier mentioned Dr. John Wilander, who was one of the, who together with me coined the term domain-driven security in 2009. Has also done some work on a proper way of doing doing validation. And he proposes the following order of different steps. Before we go into steps, just imagine that you are trying to process in-data. You get an in-data stream, and you start parsing the XML that's in there. What if that XML stream is a gigabyte big? And it contains lots of nested structures. You'll probably run out of memory or stack or something, and we will break your system. So a better order is to first check, is this data coming from a sensible origin? from a known user, from a known system. Otherwise, deflect it. Has it got a proper length? Well, I'm accepting an XML snippet here, but not an XML snippet that's a few megabytes big or a few gigabytes big. No thanks. After that, you can proceed to checking, does this have a content on a lexeme basis that is sensible? For example, if you're doing XML, you might not want to accept XML entity definitions within your XML. Anyone familiar with XML entities? Yeah, those who are not, please Google billion laughs. Or you find, there's a Wikipedia article on it. It's a way how to totally blow up the poor system by just issuing a short string that explodes into something really big.
Or you can actually also Google external entity attacks, XSE attacks, and you will actually find what that is all about. Which is
the name of this, and billion laughs is a specific form of that attack. So, often the lexeme and the parsing often collapsed into some kind of regexp or XML schema validation. But consider separating them. And finally, if a data passes through all these steps, then consider if it's semantically sound. Does this request make sense in this state of the application? Can the protocol really give me something here?
Oh man, this really sounds tedious. Have to do all this stuff in order to make sure that they get no illegal data.
Of course.
Well.
But the good part is that we're halfway, so we're pretty on time.
Yeah. So, well, the thing is that you get a lot of this just by doing the domain-driven security. You're applying your guards inside of your immutable value objects, and thereby you can actually prevent all of this, as long as you adhere to these rules. So now we have come to a point where we're going to look at complex technical attacks. And the complexity here is that it really involves more than one system. And those are really scary because those are really hard to detect.
So just to clarify, meaning that each system on its own might be sound, but we still manage to launch an attack across the system of systems.
And a common example that we find every now and then, and of course on the OWASP top 10 list, I think is number 3 on there, is cross-site scripting. And the short note to this is that untrusted data somehow gets a chance to execute inside of the browser. And this is actually a version of a second-order attack, but we'll get into that a little later. And I think the best way to explain this is really to go back to our facepalm. Again, our vulnerable application. And yes, there we are. And as it turns out, okay, now I get to write this again. Where is that pointer? I can add a comment here. Oh, sorry about that. There we go. I'm going to post a comment here. And let's say...
So people can post comments. Conceptual, this is a comment. And what Daniel's doing now is that he's actually writing a comment which contains text that, for some eyes, be very JavaScript similar. But of course, we still want to show it as text. We can imagine that this is a JavaScript chat.
Ah, yes.
Yeah,
hello.
That's really neat of you.
DDD EU. Is that good? Sounds good to me.
Okay.
Okay. So I'm going to click the submit button, and please keep your eyes open now, because this is the cool part. Oh. So now we see two things. Oh, wait a minute, let me scroll this page. Can I do that? Apparently not. You can see the beginning of that string. It says hello down there. And now get this alert box. And now when I click OK, you can see that it filled in the rest of that sentence. It says hello DDD EU. So the browser actually parsed that data from left to right as text, as code, text. Pretty scary. Just by me entering some code in there. And you can imagine this being a coder's blog. Say, hey, I'm not sure, I'm a beginner. I don't understand what JavaScript is. What is this script alert thing doing? Please help me. And apparently we get a scripting attack.
Just to be clear, to classify cross-site scripting as a second-order attack, as a complex attack, as our categorization. From the perspective where we look right now, it looks like we're attacking a single system. But we want to use domain-driven design to deepen our understanding a little bit about the nature of this attack.
So what happened, really, if you look at this from a domain perspective, it turns out when I just started writing that particular text, I was in some sort of writer's context there in the beginning, right? I was entering a question. That question was sent to another context as a comment, for instance. And that comment is stored inside some sort of persistent mechanism, probably a database. And then, when we get back to that page, or do another get of that page, we're inside of a read context. And in that context, we're supposed to interpret it as text. Pretty obvious. But what really happened was that we actually interpret that piece of comment as code. Now, what really was the flaw here is that we have forgotten to do a proper mapping between these contexts. So what we should have done is that inside of the read context, we should have realized that, wait a minute, in this context, we're going to model the comments as questions, for instance. And the data inside of that question needs to be escaped. Okay? Perfectly fine.
So just to point back a little bit, is that this is why we think that strategic design is such a key ingredient to understanding security using domain-driven design as a tool. It really opens up a lot of interesting ways of thinking about security through flaws. Okay, so let's have a look. We've looked at SQL injection, and we can note that SQL injection is going from the attack vector of the presentation tier through the application and then hitting the database. Okay? Whereas cross-site scripting is entering the system through a web browser into the application, down in the database where they store the application text, the comment, and then it's interpreted and it hit up from the application, interpreted in the reader browser, where it hits the browser and causing the flaw, or causing the problem. Well, to be complete, the cross-site scripting need not necessarily be stored in the database. It might, there are versions which just touches the application and then goes up. They're called a mirrored attack or reflected attack, not a stored cross-site scripting. So, but these two, when drawn this way as stacks, they look very different. They look like two very different attacks. And that is how they have been perceived this far. However, if we redraw this a little bit, with domain modeling, strategic design, strategic bounded context, context mapping mindset, we might draw them this way instead. From the browser to the application down, and here our content is suddenly interpreted as code. Or start here, pass through the application, and here our content is interpreted as code. Now, do these two look fundamentally different? No, actually, they look pretty similar. So this is why we would like to stress that we see the cross-site scripting and injection flaw as actually there are more two versions of the same kind of attack where we confuse things by jumping across bounded contexts between domains. And I think personally, this way of drawing architecture, not as stacks, but rather as hexagons, is very fruitful. And one has heard about hexagonal architecture. Yeah, hexagonal architecture is, to me, just a way of drawing the architecture. It has hexagons. But it clarifies that's not necessarily an up and down. They're rather insides and outsides, referring to systems. And we're jumping across subsystem borders. It's very powerful, especially as it makes it easier to understand other concepts that can be really hard to grasp. For example, in security, we've got second-order injection attacks. What the? So second order is when you're not attacking an injection attack at the system in front of you, but at the system that is behind that system. For example, crafting an injection string that is not attacking the system in front of me, but putting into the username so many times that suddenly the system reacts by adding it to a security log, saying, we got an intrusion detection here. This username is fishy. Now, the sysadmin will look at the log file using a log file analysis tool, which we happen to know is written in Python and sensible for some specific vulnerabilities, and upon them one of the string that we crafted as username. So the injection attack will manifest in the log analysis tool. Bam! Deep inside the system, and probably they've got a lot of admin rights at the time right there. So it's a really good thing for us as a hacker to be able to launch that far into the system. And this can easily be understood. We're going through the web, server, log, and then bang, we're attacking the log admin. And using this domain-driven design, influenced perspective and mindset, the solution's so simple. We see that it's a broken context mapping. So this is one part of second-order attack, second-order problems. Another is that we can inadvertently leak data from, for example, a log, and then can be into the log and can be viewed in some log tool or something.
And that's actually, we've come up with a pattern, or actually one of our colleagues, Daniel Savano, and that's not to be confused with the guy who wrote Facepalm, Daniel Hultqvist. You have really bad entropy and names at Omega Point.
We should change our employment strategy. I think there should be a policy.
Yeah.
Daniel. We actually got a few more Daniels, but
yeah.
Never mind.
So
and one more Dan. And a Dana.
This pattern is actually quite useful in the sense that it protects you from accidentally reading a value twice. It's very simple. And you should not be able to externalize it. You cannot invoke equal hash code. This actually goes on a little bit. And as soon as you've read it, that guard will trip the next time you invoke it. And then you will most likely catch this in your test suites or whatever you do by accidentally logging this value or reading it and using it somewhere that you're not supposed to do. And you can start discussing it and see what's going on. So it's really nice to actually wrap your sensitive data in those kind of wrappers. Tip of the day. So, right. So how did DDSEC help us out? Well, as it turns out, context mapping was really the tool for us to get a deeper insight of cross-site scripting. It also allowed us to detect broken maps that could be exploited in second-order attacks. Pretty neat. And by modeling confidentiality, sensitive data, we were able to avoid, or at least try to avoid, accidental leakage. Which is pretty neat.
Okay, so let's move over to the last of our findings. These are most recent findings and insights about complex domains. Remember the initial example, where the order went to the finance system and the finance system sent out money? Let's elaborate this a little bit. Imagine that we've got a storage system and a shipping system. The storage system also receives -1. It will react by decreasing an amount, so it will add 1 in the storage inventory. The shipping system will get an order to ship -1 and encyclopedia, and will just think this is bizarre. It will just drop it and add another entry onto the system log where there's a gazillion exceptions that no one will ever look at. So the result is that we actually ship it. Sorry, we did not ship it. We send out the money and we increase the inventory. Thus, these systems are still consistent, and this will not be detected.
But come on, Dan. The reason why this really worked is because there's a bug.
I stand corrected.
Yeah.
Just pointing out that it will probably be detected at the end of year inventory when they realize that there's 1 book too little in the storage, and the storage guys will be blamed. But I stand corrected. We craft an example instead where we have no system containing a bug, and we still end up in a bad place. Real-life example. An insurance company with a payment system which handles payments and policies. They try to go microservice-ish, so they break it up into 2 systems. When a payment arrives, a policy is prolonged, and the letter is sent to the customer. Now, they suddenly want to add Jira payment. The payment before was cash over counter. Now they add bank Jira payment, so a payment will still send a payment, and the policy will be prolonged, and the bank might send a confirm or Jira reject, so we will end up with a Jira confirm or a Jira bounce. Fair enough. Which is just fine until someone adds a Jira payment that will increase the payment and policy will be prolonged, but we got a Jira reject and a Jira bounce. And that will be handled by the purchase department and the finance. However, the insurance people will still see this as a valid policy. So we will have people not paying, but still getting valid policies. And imagine imagine that this instead was not 3 services, but 300 services.
And I might also add that since we are moving away from that monolith into a lot of microservices, somehow we get a approval that we can do, surgical micro changes. So we don't have to affect anyone else except this microservice. That's really what we can do. It's so powerful. So we can do this minor change, and it will just be magic. We don't need to involve anybody else.
So basically, that's the claim that we want to refute. Okay, instead, we of course should have done all the modeling and changing the payment to cash payment. We would break the downstream technical constraint. These people will get angry at us, but at least we would not break the semantic dependency. So having a discussion with the domain experts over here and over here in both insurance and purchase to actually make it all together fit. I think we are heading for a microservice hellhole because we cannot do these surgical changes.
Right. So let's wrap things up.
That's
what
the key
are the key takeaways? In case you have fallen asleep and woke up right now, you realize that DDSEC will actually help you to design secure software without having to think actively on security. And this is such a nice tool in your, and also a good argument for you when you have to push for doing DDD.
And we want to treat injection flaws as a modeling problem, thus, rather than a validation problem.
And of course, context mapping was a very good tool for you to discover broken maps and thereby preventing second-order attacks and cross-site scripting and such.
And finally, we think microservices, they're scary as hell, unless the world actually gets a grip on context mapping. So this is basically the current state, future direction. We're working together with academia and doing research. We continue to work every day, and we are just in an early process of writing a book on this subject, and we hope that will be interesting. Thank you for your attention.